Hello and welcome back to another festive coding session with Mr. Jacob, where we are in the 16th day of our Advent of Languages, where we strive to implement in the 24 first days of December the same thing in a different language each day. And yesterday we did something with ARM64 assembler, something very near to the bare metal that our machine is here. And today we want to do something with Lua, and we want to implement, as always, more or less a representation of this ASCII art Christmas tree in a slightly configurable manner. We will see. And Lua essentially usually is some sort of scripting language, or not some sort of, it is a scripting language which is used within a lot of different other projects and programs usually. So it is embedded in games, for example, to control them. It is embedded in, for example, my terminal emulator here, which essentially really is configured by Lua. It is used by NeoWim, for example, for its scripting extensions and its configuration. And it's used by a lot of different software projects out there as an embedded language to be used to interact with the system and program some sort of application. However, it can be used as a standalone script there as well. It usually does not make very much sense, but we can do something like hello Xmas Lua, and we can do something like print hello Xmas. And if I now do a Lua, I have a Lua interpreter actually on my system. I can interpret that and I get hello Xmas there. So we can essentially use what is usually liblua, the system that, or the library that we embed, as an executable to simply use this and execute this. In most situations, you wouldn't use that standalone. However, you can if you want to. So we can write our application in it, our tree creation application. So let's first of all get something like maybe our tree as a reference here. So let's quickly get that. Wait, what did I do there? I just wanted to exactly get that out of there, put that there, remove that and comment that one out. And now let's remove those unnecessary indentations there. And as you can already see, the comment sign of Lua is double dash. And now we want to create something like that. And I think we should do that by simply creating a function which actually creates this tree. So we start with function make tree. And this thing, as always, takes the number of groups that we have, or better said, the length of our tree. So the number of those thingies here, those zigzag tree shape thingies. So this tree here actually has 3 groups, because we identified before that essentially every dimension and every sizing of the tree can be determined by knowing how much of those groups we actually have. A function actually is declared simply using the function keyword, the name, the properties, and so the arguments and so on. And as in contrast with many other languages, we don't use indentations for block scoping or for making this block, or we don't use curly braces, but we use simply the function keyword in this situation and the end keyword to signal the system, okay, here this function ends there. And this is the same with loops, with ifs, and so on and so on. So what actually we want here now is we want for now to return something. So let's maybe just return a string here now, hello Xmas, and let's see that we can call that. So maybe we do something like tree. If we want to assign a variable, we simply define that variable. We say equals, and we define, and we actually assign it. We can actually now call this one like this, or I think we could just leave the braces out there. I think they are optional, as well as semicolons. They are actually optional as well. So let's quickly check that this kind of still works. Wait a second, Lua %. So yeah, it still executes, or we didn't print that. So let's print our tree here just to see something, and we see hello Xmas, perfect. So if I now leave out the braces and simply do a space there, would that be the same? It would not be the same. However, as far as I know, with strings, you can actually do that. So let's try that, for example, here. hello Xmas. So with strings that works actually. I'm not 100% sure when you can leave out the braces and when not, but I'm usually in Lua using the braces. So as you can see, this is essentially how you print something out. However, I think we need to return multiple lines. So I guess we want to return something that is kind of an array. In Lua, we have actually something called tables. And tables are actually something that is quite interesting. They more or less resemble something more to a dynamic array, which we already saw in PHP. As in they can have numeric indices and therefore work as arrays, and they can have string indices and therefore work as a hash map. So how do we define them? We are actually using the curly braces there to define a table. And we can then put something in there, for example, by doing it like that. And we could then do return output here. And now we would have returned this table here. If we would like to set something as a key value pair, we can actually do something like you can do it like that. So simply defining key equals value, and it will be set, the key will be set to the corresponding value. However, in our situation, we only want that. For now, we will do that dynamically, of course, in a second. How can we now print those informations here? We can do something, for example, we can iterate it. We can iterate over the tables, and we will see in a second why I have this underscore there. Let's iterate over the line here by simply doing something like for something in. That's the way how to iterate. And then we say I pairs. And then we say tree. And we want to do here something. And then we want to end. And we want to go in here. Let me quickly grab that. And put it there. And give it the line here. And this should actually print the contents of our tree. Let's check that it does. Okay, it does. Yeah, why does it do it? And what's up with this and the I pairs there? So essentially, as a table, as I've said, always is a combination of key and value, either an integer key and an arbitrary value, or an string key and an arbitrary value. We have those pairs functions. We have either pairs or we have I pairs. I pairs, as the name suggests, gives you the integer pairs of a table. As this pair here, so I actually have something like an I here that I could print out. And now you should see, okay, we have one entry, we have the one entry, and hello Xmas. That's actually something quite interesting to be kept in mind when you are using Lua. Lua actually uses one-based table or array indexing, so to speak. However, we don't need this value, so we simply say we don't need it using an underscore, then it will simply be not set, and we can actually not reference it. I'm not even sure if we are actually setting it to something like, yeah, okay, we are actually setting it to the underscore variable name here. However, this is kind of a convention on how to denounce or to say that that we aren't interested in a certain variable. We can use that over and over again and use that for other iterations as well, or for other situations where we are not interested in the value. So that is how you iterate over tables. So now that we have that possibility and to actually output that, let's see how we can actually create our tree here. So we are now actually creating our output here by doing something like creating an empty output. However, no, I've missed to tell you something. So let's quickly go back to something like that. Because we have a slight problem. I'm printing out the tree variable here now. But if I now do that, and I would print output, I would actually iterate output, which should only exist within this function here. We are getting a result as well, because output is defined out here as well. That is because every variable that we define in Lua is by default global. So it is not only global to this file here, it is global to the whole interpreting context of Lua. So if we would have more than one file, it would be global to simply everything. And to actually scope it, to not make it leak out of this scope, this function scope here, we simply declared with a local keyword before it. However, as I've said, it's global to the whole interpreting context. So everything in this file as well is global as well. If we don't want that, we need to declare those variables here, these outside variables, local as well. And if I do that now, we can see that it tells us that an index nil value was attempted to be indexed. So everything that is not set in Lua is actually a nil value. And that is actually the error here. We are trying to index output, which now isn't there anymore. So it's exactly what we wanted. However, the same thing is true for functions. So we need to make this function local to this module here as well, by just putting local in front of it. The reason for that is that functions actually are first-class citizens. So I could have done something here, like, for example, local foobar is a function which takes no arguments and prints something like foobar and then ends. And then I could simply call foobar here. And this should actually work as well. You can see that there, foobar. So it actually is allowed to use a function, for example, as an expression. It is a first-class citizen. You can pass it around as an argument and all that kind of stuff. Okay, so enough basic information here. Let's get going implementing our Christmas tree. Now you know a little bit about the scoping, the functions, all the stuff in Lua. So how would we actually go ahead and do that? Of course, first we need to kind of iterate for all of those groups here, as we have always identified. These zigzagging shapes, those are the amount of length. This is what we give in here. So that is what we want to iterate. And to iterate integers in Lua is actually quite easy. You simply tell it that you want to iterate, for example, from 0 to the amount where we want to iterate inclusive, separated by a comma. So I want to go to length -1. And then I simply say do, and I put an end at the end. And now if I do that, I can actually do something like print I here. And it should actually print, as you can see, our loop. Perfect. So now we can work with that. We can actually put something into our output table here within our loops that is looping through the groups. And as we know from all the previous implementations, what we need are separate parts for those, for those spaces here, for those spaces in between, and the slash and the backslash. And how can we actually achieve that? We can actually create a string like that, for example, using something like we define, for example, local line 1, and line 1 would be a string consisting of something like string, and then we are saying repeat, for example, or rep is it called? Perfect, it's called rep, which can actually repeat a certain string, and therefore we can use it to simply repeat a specific amount of times our spaces here, and the amount of times that we need our spaces here is actually length -I spaces. And we need actually a space here, so this should do it. Then we can concatenate strings in Lua with dot operations, so we are then concatenating to it the slash. Then we are concatenating here string rep, and we are giving it in this situation I times 2. However, I just realized we usually name this one not I, but n. Let's name it here n as well, because I've by now started to remember it in this situation as n. So that is the number of spaces that we actually need in between those things here. So we are here for the first line at n equals 0, so 0 spaces, and then for the second we will see in a second. So what is then, that needs then to be followed by a backslash, and then we are ready with our local line 1. So let's quickly copy that and do the same thing more or less for line 2. Something like in the vicinity of we need 1 space less in the front because we are 1 moved to the left, and we need here n+1 spaces because in each second line we are using the same spacing as the one that is following directly, as you can see there. So now we have those two lines, so we need to put them somehow in output. And to put something into a table here, we can actually use the functionality which is defined on a table, because the table actually gives us something like insert. So we can actually tell insert to this table, and we say, okay, we want output as a target table kind of, and we want to insert something into it. We want to insert line 1 into it. And usually I think you give it the position. I'm not 100% sure. However, I think you do. And therefore we need to give it the position where to insert. I'm not sure if this is optional or not. However, it's another good a good thing here to explain something to you. You can always get the size of a table, how many elements are actually in there, by simply using the hash sign in front of the table name. So this is essentially something like you get me the length of that table. So this should actually work. So now let's insert line 2 as well, and let's actually see if it already created part of our Christmas tree. And of course it did not, because I did something wrong there. So calling wrap on bad self, string expected, got table. Okay, what did I do? What did I do here wrong? Oh, I see. I did a colon here and not a dot. I wanted to access something on this table, so to speak, and I guess I have made the same thing here with our inserts. Yeah. Colon you can actually use to access something from the meta table of something. You can actually use that to kind of define something like instance methods on things. However, that would now really go too far with regarding the time of this those videos here. So let's try if this now works actually. So it still does not work. Bad argument 2 to wrap. Number expected got string. So what I essentially I think I did this the wrong way around. Yeah, which makes perfect sense, because I called it in a way which would have been called on a string. So essentially I guess I could have done something like that as well if I used the colon there. That might actually have worked. Let's see if that actually would work here, and let's keep the others as we think they should be, like that. Did I do that right? No, that's a bracket too much. And there we have this one as well. So let's see. Okay. And let's try it now. And unexpected symbol near colon. So this does not work. Okay. However, essentially something like this, I'm not doing it right, but something like this should actually be kind of possible. So, okay, what's the next thing? Bad argument to insert, position out of bounds. Okay, either I did something wrong here and this is not needed, or I should have done -1. Okay, it seems it's not needed and it will be added to the end if I don't specify it. Take a look at the documentation if you want to know what I did wrong there, because I think you can give insert actually, can we actually see that quickly? No, it's not. Okay, no manual entry. Too bad. There is some way to specify the position where to insert something, but it seems that it does that on the end of the table by default. Okay, so now we have those. So now we need to actually add this divider line here. So let's add this divider line quickly, and this would be done by simply inserting table insert into the output, and we can insert a line there, which is simply a string repetition of the string minus, and it's length times 2 plus 2, if I remember correctly. Yeah, that makes sense, because to the half of it, yeah. And then we need the both outer characters as well. So this should actually work. And now we need the trunk, and we can actually table insert this one directly as well. So output, string wrap, and we need spacing there first. And essentially the spacing is exactly not groups, but length. It is the length here that we are actually, that we need as a spacing, and that is actually followed by 2 pipe characters, because those are making up our trunk, and we need to do this 2 times. And now if we take a look, we actually have that tree. And why was I speeding through this quite a lot and did not make this out into different functions or anything like that? Because I want to try and quickly hack something together which uses this Lua script within a Rust application now using the mlua crate to actually execute that. And we have to change a little bit of that because we want to actually call this make tree and then return this instead of actually printing it out. So we will simply change this code here to say return tree in the end. So we want to return from this module all of this stuff. We want to return this table back to whoever called us, and we won't do this anymore. So let's comment that out. Let's quickly save that, and let's quickly get some sort of Rust project going here. So let's quickly do a cargo init there. Okay, yeah. We need to do something like, I guess, name Lua or Advent of languages Lua, something like that. Okay, so now we actually should have a source file here, and let's quickly add cargo add. It's called mlua. That's actually the go-to thingy to embed Lua into your cargo projects there. So let's quickly see. Let's go to source main rs. Yeah. My Vim is not perfectly configured for Rust, but let's see. First of all, we need to import something like mlua prelude, if I'm thinking correctly here. And we don't need that. We need to create our Lua interpreter first, kind of. So let Lua equal Lua new. This will essentially be, if I remember correctly, our Lua context. And now we need to load our Lua file here, and I guess the quickest way to get that in there would be something like include str, which actually is a macro that will simply load the file at compile time and inject it at this position. Usually, of course, you would kind of load the file dynamically or something like that. So it would be somewhere, where do we actually put it? One directory down out of our source directory called hello Xmas Lua. That's our file there. And now after we have loaded it, we can actually tell Lua we want it evaluated, and it might fail because the Lua might be defect. So what we can actually return here is an mlua result of sorts. So maybe we should then do that by returning OK here in the end. And now we should actually have that. However, now we can kind of catch the return of the eval Lua here. So we can, of course, define certain functions now to be bridged into Lua. So we can define a function here in Rust that is then called if a certain Lua function is called, and the other way around, and all of that is possible. However, we simply want to get this this table out of there. So I guess we could call that tree, and I think we need to supply the type here, and I think it is an mlua table that we get back here. And if we get something else back, it should actually panic here, because then errors should be actually created here. Okay, now we have this table. Hopefully, we should be able to iterate it. However, it's a Lua table, and as we remember, Lua tables have always this concept of pairs and stuff like that. So we are essentially doing the same thing in Rust. We are iterating an entry and a pair of those lines here. So I guess what we are doing here is we are just telling the tree, and I think there was something like I pairs or iter. There is something like that. Pairs, yeah, table pairs returns an iterator over the pairs of the table. This works like the Lua pairs function, but does not invoke the pairs meta method. Meta methods, by the way, are those things I explained with the double with the colon and stuff like that. And yeah, let's try this one, and actually let's see. Let's see if we can actually do something with that and then just print line the line. However, I'm not sure that this will work. I guess there will be some typing missing or something like that. So let's quickly store that and let's see if we can actually cargo run this thing. You can enable only one of the features. Lua, okay. So I guess we need to cargo add mlua, and we want, I don't know, the newest Lua 5.4 or something like that. So -f Lua 5.4, something like that. Yeah, and let's see if it's now working. It's compiling. Of course, it's not. I kind of did only a single colon there. However, I needed a double colon, of course. And now what's the problem? This is an iterator with items of type result something Lua array. Okay, so first of all, we are getting, this iterator can actually fail. So this would be something like pairs then. So let's get those and then let's do something like we don't care about that. We want this one as a line and we want pair, no, that's not pairs, but pair actually, and we want the pair here, and it might actually be a not okay result, so it might be an array. However, I think it will still not work. Yeah. Could not compile due to one previous error. You might be missing string literal. Format argument must be a string literal. Okay, and I guess that's the problem because we don't have a real type for this thing. I think if I remember correctly, you can do something like that. I could tell it that I want actually I32 string. Is that actually a thing that I could do? No. Format argument must be string. Oh, string literal. Yes. I need to do something like that, don't I? So maybe that's what it tried to tell me. Hey, perfect. So so as you can see now, with only a couple of lines of code, we have actually embedded our Lua file into our Rust program. It's dynamically evaluated and it is then run. So actually what we can do now here is we can change things in our Lua file. Like for example, we make this tree bigger before here returning it, and we don't even really need this this temporary tree variable here anymore. So just return the result of make tree, why not? And if I now do cargo run, it is built and it is bigger. And if I do something ridiculous, like for example 12, which won't even fit my terminal, I guess, it will still work and it will execute this specific Lua file and it will run it, and it is now a scripting language possibility within our Rust application. And for more or less every programming language out there, there is some sort of Lua binding. I think that is a great achievement that we did here today. We created a Lua script and even embedded it into our Rust environment here simply, and I just did Rust because that was what now was the fastest thing for me to actually do and embed Lua there. I hope you learned something about Lua. I hope you learned something about the way that this can actually be used, and maybe you are interested in taking a further look at it, or you just had fun joining me in this Advent of Languages installment here where we took a look at Lua. And I hope you will join me tomorrow when there is another language on in the Advent of Languages. So I hope to see you in the next one. Bye!